Okay, so now let's expand on to the second type of question, so volumes of revolution around the y-axis. So very similar idea to the ones around the x-axis, except this time we've got to rotate it around the y-axis. So here, if you imagine this rotating this shape, you're going to get like the way I've drawn it, it looks like a bell shape, but with the top sliced off. So between those two limits, what do I need to do? Well, the idea here is to also think about this little lot, loads of those cylinders that are being added together, like in the example before. So imagine this thickness of that cylinder. I've done it so small. Let's just do it there. It's going to be delta. Now we are along the y-axis, so delta y. Okay. Now what is that radius of this? If you could slice it up cross section, well, the radius here is going to be the x coordinate of that point. Okay, so thinking about it, let's think about one cylinder. One tiny cylinder will have the volume of pi, so let's do the cross section, which is a circle, pi r squared, which happens to be our x, multiplied by delta y. And this is actually already our formula, except we will have infinite number of those slices. So the volume around the y-axis, and let's put pi in front of it, and you'll have x squared dy. Between the limits, now the limits are the y values, so this is your y equals a is the lower limit and y equals b. I wrote y and over here so you don't accidentally put the x coordinates here. So really everything that you had for the volumes of revolution around the x-axis, if you switch the x's with y's, you'll get the formula for the volumes of revolution around the y-axis. So let's see if we can do it. So here we've got to find the volume of revolution if this little section is flipped around the y-axis, okay, through 360 degrees or 2 pi, which is exactly the same. So first of all, they mention around the y-axis, so we need to quote the formula. So it's going to be between the limits, let's call it in general terms, I'm just going to rewrite this formula, x squared dy. So in our case, you've got clear limits 1 and 3. X squared, well, what is our x squared? Well, if y is equal to x minus 1, then y squared is equal to x minus 1. So x is equal to y squared plus 1. Therefore, x squared is going to be y squared plus 1 all squared. Let me expand it. So it's going to be y to the power 4 plus 2y squared plus 1. So sometimes you need to prepare it so we into rearrange it to make extra subjects and then square it. So let's integrate. So it's going to be y to the power 5 over 5 plus 2y cubed over 3 plus y between the limits y1 and 3. Okay, and let's now put the limits in, show clearly that you are popping those in. So it's going to be 3 to the power 5 over 5 plus 2 times 3 cubed over 3 plus 3 minus, let's pop 1 in, so it's 1 to the power 5 over 5 plus 2 times 1 to the power 3 over 3 plus 1. You can do them separately, but you can also use the ANS key, so that's what I'm going to do. So the first one is ANS. I'll put ANS to the power of 5 divided by 5 plus 2 ANS is my y to the power of 3. I use divide, you can use the fraction symbol, plus ANS Okay, so the first number I'm going to put is 3, so put 3 equals, scroll up, find the rule, which is fair. So it's going to be, the first evaluated limit is 348 over 5, minus, let's put 1 in, so 1 equals, that becomes your ans. Sub it in, 28 over 15. So if I go back there, just do that again. So it's 348 minus 28 divided by 15. That is 1016 over 15 pi, which is 67. I'm not times it by pi. It's 213 to 3 significant figures. Okay, so now I think you'll be ready to go, unless there's another example. Let me just double check. Example, there's only one example. You can go on to exercise 5B.